Hi, today I've got an Engl Screamer 50 combo and it's not working. Well, a part of it is not working. The low high gain switch is not working. So I'm going to take this amp into my lab and see what's wrong with it and see if I can fix it. So I've got the amp set up in my lab now, so let's try and reproduce the issue. So if I hit the gain switch, the light doesn't come on, I don't hear any relays click. But if I do the same thing with the lead switch, then it does, the light does come on. I do hear the relays click, so there's obviously something wrong there with the gain switch. Let's have a look at the schematic now and see if we can see what might be wrong. I found this schematic on the internet and the switching portion is in the bottom left hand corner. Let's zoom into that. This is the yellow LED that isn't turning on, and this here is the relay that isn't switching. The top line is the 24 volt rail for the switching portion of the circuit. The relay and the LED are in series, and the switch at the bottom left is the front panel switch that completes the circuit. So any of the components along this red line could be bad. So let's start with the LED, because we can actually see that that's not shining, so it could be that the LED has failed. Let's test it. So I've got the amp set up on my bench now, and what surprised me is that the transformer is actually very small. Considering how heavy this amp is, this amp is very heavy, I would have expected the transformers to be larger, but actually all the weight is in the cabinet, and in particular the metal grill in front of the speaker also weighs a ton and contributes to the enormous weight of this amp. So I've got my multimeter set to the diode setting now, and it reads a forward voltage of around 1.8 volts for that LED, and it seems to be perfectly fine. So now I'm going to measure the resistance from the cathode of the LED to ground, and there should be none or close to none when the switch is engaged, and there should be an infinite amount when the switch is off. And that will, if that test passes, then we can rule out there being a problem in any of the downstream components of that LED. So that test passed just fine, which tells me that the relay RE6 is not the problem, and neither is the switch. So the problem is either with the 100 ohm resistor or with the relay RE2. And my suspicion is that it's the relay, but let's find out. So when the relay is in the off position, there's a small amount of current flowing along the orange line here. And I'm interested in the voltage at the other end of the relay coil, so where this blue arrow is pointing. Now let's, for the moment, forget about this transistor T3. If we look at the data sheet for the relay, we can see that the resistance of the relay coil is 2.88K. So here's a simplified diagram of the orange subcircuit minus the transistor. We can just use the voltage divider rule to find out the voltages at the different nodes. And you can see that at the base of that transistor, so between the 10K and 100K resistors, the voltage is 2.12 volts, which is enough to turn the transistor on. So let's replace the 10K resistor with the base emitter voltage of the transistor, which is 0.7 volts, and use the voltage divider rule to figure out that the voltage at the other end of the relay coil will be 23.35 volts, and that should be the actual voltage now, because we've taken the transistor into account. Now when the switch turns the relay on, it diverts current along the red trace here, which goes through the LED and the switch. Here's a simplified diagram of the red subcircuit, and again, using the voltage divider rule, we can see that the voltage at the other end of the relay coil will be 2.54 volts this time. So in summary, the voltages at this node are 23.35 volts when the relay is off, so when the switch is off, and 2.54 volts when the switch is on. So let's see if we can measure those voltages. So the tricky part now is to find where the relay is on the circuit board. Now if we look at the schematic again, the switching happens in the top left hand part of the circuit diagram. Zooming in, these two switches are controlled by the relay in question. Now if we look at the amp, there's a big metal screen covering that portion of the circuit, so I'll have to remove that first. So I've removed the screen, and as you can see, all the components are attached to the bottom of the board, so I can't actually see them, and I can't see the relay that I'm trying to find. But I can see what looks suspiciously like relay footprints here. And by comparing the traces on the top of the board to the schematic, I've established that the left footprint is of the relay that I believe is faulty, and the right footprint is for the relay that's controlled by the lead switch. So let's start with a functioning relay and measure the coil voltage. So in the off position it reads 23.95 volts, and in the on position it reads 2.91 volts. So both of these readings are slightly higher than what I calculated, but I am running the amp at 240 volts instead of 230 volts. And also there'll be, component tolerances which might make the voltages slightly higher, but they're not too far off really, and good enough. So moving over to what I believe is the bad relay now. If we measure the coil voltage, it reads 0.4 volts both in the off and the on position, so there's definitely something wrong here. And the only way that can happen is if we have a bad relay coil, so I need to replace this relay. So I desoldered the old relay, it just dropped out, and now I need to order a new one. The new relay just arrived today, and it's black instead of white, but it has exactly the same part number as the white one, so I'm sure it's the same thing. Let's put it in and see if it fixes the problem. So I've replaced the relay now, and I've got the amp set up on my bench with a multimeter set to the voltage mode connected to that node that we were probing before. And remember, before it was reading 0.4 volts in both the off and the on position. Now it's reading 23.61 volts in the off position, so that's a good start. And if we turn the switch on, the LED lights up, which it wasn't doing before, and the voltage at that node drops to 2.7 volts. So that's exactly as we would expect for a functioning relay. Not only that, I can hear the relay click, so things are working, and I couldn't even hear the click before. So it looks like that was the issue, and it's now fixed. So I just tested the amp out and it's working perfectly, so the repair was a success. If you want to hear what the amp sounds like, I'll do a demo video in the near future and release it on my channel, so please subscribe to my channel if you want to be notified of that video when it comes out. Also, please subscribe if you want to see more videos like this one. Give it a thumbs up if you liked it. Check me out on Instagram at Rajani Amps. Check me out online at rajaniamps.com, and I hope to see you next time.